Okay, in this video we're going to finish out our discussion of quadratic functions this week, and we're going to turn our attention to the graphs of quadratic functions. Now if you think about the two big concepts that we learned about this week, that's again finding our x-intercepts and vertex of quadratic functions. So if we know where the graph crosses the x-axis and where the peak or valley of the parabola is, then we should be able to determine a general behavior or an image in our mind of what the graph would look like without having to go to a graphing calculator. So the first thing that we're going to do is pick a few of these examples. There are 8 here, and we may not go through all of them in this video, but pick a few of these examples and we're going to identify the vertex and the x-intercepts. So one more time as a reminder, the x-intercepts we also know as roots. We know them as solutions. We've used the term zeros, and all of these terms can be used interchangeably: roots, solutions, zeros, x-intercepts, and all 4 of those are found by using our quadratic formula. The vertex is found by using the vertex formula, and both of which we've programmed into our TI Inspire calculators now. So if you saw me in class this week, we were building them together, and if you didn't have me in class, then I told you to go and access the 2 videos that I've got posted on my channel to see the technique for that. Now what I've done is I created one more document with the quadratic formulas and the vertex formulas built into them. So now I have a single document. I've titled it Algebra 2. But now I have a single document that has both of those equations built into it. And we'll utilize that today in this video. Okay, so here we go. Let's just go ahead and start with number 11 here. If our goal is to find the graph A, B, C, D, E, F, G, or H that matches equation number 11, I think the first thing that we might do is we might try to find the vertex, and then from there we'll find our x-intercepts using the quadratic formula. So before I begin, I'm going to note that in problem number 11, I know there's not a whole lot of room to write this, but I'll jot it down up here. In problem 11, we have an A value of 1, we have a B value of 0, and a C value of -1. I say that the B value is 0 because there is no term in the middle that contains the letter x. If there's no term that contains the letter x, then that B coefficient must have been 0. The C value, the number that's all by itself at the end, is -1. So if I run my vertex equation in my graphing calculator with an A value of 1, B 0, and C -1, we should be able to identify the vertex of this graph. So I'll go ahead and type that in. We've got vertex, parentheses, 1, comma, 0, comma, -1, and press enter. And when we built this equation, we said that even though these aren't the correct symbols to represent a coordinate, they can be assumed as such here. So we know that the vertex occurs at the x-coordinate of 0 and the y-coordinate of -1. So I'm just going to make a note here. The vertex is at 0, comma, -1. Now if that's sufficient for us to identify the graph, then in a testing situation, then I would probably tell you to select that option. And it looks like option C is the only one that has an x-coordinate of 0 and a y-coordinate of -1 for the vertex of the graph. So I already am led to believe that the graph that matches number 11 is graph C. But let's go ahead and check our quadratic formulas as well. If we check QFM and QFP, quadratic formula with a plus and quadratic formula with a minus, that should also represent our x-intercepts, and we should see answers of +1 and -1 if graph C is the match. So let's go ahead and check that. We'll type in QFP for quadratic formula plus with the same numbers, 1, 0, -1, and there's a +1 as an answer. And if we run the QFM calculation, we end up with -1. So that's enough for me to say that our x-intercepts occur at x equals 1 and x equals -1, And again, those were found by using the quadratic formula. So the only graph that matches a vertex at 0, -1, and x-intercepts at +1 and -1 is indeed graph C. Let's try one of these over here on the right-hand side. What about number 14? With number 14, the vertex can be found, I hope, and we should have x-intercepts at 2 locations. Let's see what we get there. So in this case, we have an a value of 1, b value of 2, and a c value of 1. So let's go ahead and run our vertex. I'm just going to copy and paste this here so I don't have to type it all over again. A value was 1, b value was 2, and our c value, I believe, was +1. Let me just double check that before I commit to that answer. Yep, 1, 2, and +1 again. So it looks like we have a vertex at the coordinate -1, 0. And if I'm looking for the quadratic formula for both the positive and negative form of the answer, or the plus sign and the minus sign, I should say, we'll use 1, 2, and +1 again for the quadratic formula. So we got a -1 as a result. And another -1 as a result. Now that's kind of interesting. Both quadratic formulas with a plus sign and a minus sign produce an x-intercept at -1. Interesting. So x equals -1 and x equals -1. Well, what's that going to look like? If I draw a quick xy axis, I know I have a vertex at -1, 0, but I also have an x-intercept at -1 and at -1 again. So all three of those points coincide with one another. That's this position here. So what's that mean? Well, that means that this quadratic function can either be a U-shape that opens up or down from that position. There are no other x-intercepts, so this graph will not cross the x-axis anymore, and the vertex itself lies perfectly on the x-axis as well. So we've got to decide, is the graph going to look like this option above or this option below the x-axis? Well, as it turns out, we can determine this answer by looking at one more piece of data, and that's this a value up front. This a value up front gives us a direction to our quadratics. When the a value is positive, or when it's bigger than 0, the graph is going to open up, we say. The tails themselves are going to be pointing upward. It's like we're opening upward. If a is negative or less than 0, then that means that our graph is going to open down. So now, if we had in a case like this where our x-intercepts weren't all that helpful for us, we at least have an idea for the direction that the graph is going to point. So that takes care of number 14 then. Let's go ahead and look at 18 while we're here. With 18, it looks like we've got an a value of 1, a b value of 2, and a c value of 2 this time. So 1, 2, and 2. It's real similar to what we saw a minute ago, so let's see how this will change our graph. I'm going to use the vertex formula first. Vertex is with an a value of 1, b value of 2, and a c value of 2 is going to be at the coordinate -1, 1. So this means we've got a vertex at -1, 1. And we also have to use the quadratic formula, both positive, with a plus sign and with a minus sign. So QFP with 1, 2, 2, and QFM with 1, 2, and 2. Now the quadratic formulas end up producing an answer that contain this imaginary number. From class we noted that these imaginary numbers imply that there are no x-intercepts. So as far as x-intercepts, we have to say none. There are no x-intercepts because the solution to this quadratic can't be found on our real number line. They can only be found with imaginary or complex numbers. We can't show complex numbers on our current graphing scheme, so we can't show any x-intercepts. Well, what's that mean for the graph? If you've been looking at your answer options, I bet you already know which solution we're going to choose. But let's just make a note of this here, that the x value was -1 and the y value was +1 in order to place our vertex. But now we've got to decide, well, where does the rest of this graph live? Does it point upward or downward in this U shape? Well, if you think that it points downward, you should quickly realize that that's no good, because if it points downward, then there should have been x-intercepts that we found as part of our solution. But we didn't find any. So in actuality, this graph does open up just like the last one, and we've got two clues that tell us that now. First clue, of course, was that our a value was positive. That should tell you that it opens up. But our second clue was this: there were no x-intercepts. And so the only way that I can have a graph, a quadratic graph that forms this U-shaped parabola, that starts here at this position and does not touch the x-axis, is if that graph opens upward. So I think option D was the best choice for number 18. I think we forgot to mention which was the answer for number 14. Let's see here, C was used, D was used, and number 14 kind of looks like option A was the answer there. So for a challenge, I'd ask that you complete the rest of these, identify the vertex and the x-intercepts for the remaining, 5 examples here, and see if you can match the graphs. Let me know if you have any questions while working on that. In this group of questions, the instructions say to solve by completing the square. We're not going to use that technique in this video because this isn't a process that we're going to cover in class this year. But this completing the square method is an algebraic technique that allows us to find the vertex. Okay, completing the square often allows us to find what we call the vertex form of a quadratic equation, and we can identify the vertex from there. Once we have the vertex in place, we can also imagine where the x-intercepts occur. And when we solve each equation, remember we said that the solutions to a quadratic end up being our x-intercepts. So I don't mean to make this question confusing at all, but if our job was simply just to solve each equation, if we were just looking for a solution, we would find our x-intercepts by using the quadratic formula. If we were going to use the completing the square method as described here, that means we should find the vertex first and then determine the x-intercepts after. So again, we're going to kind of avoid this method in this video. We don't need to find the vertex here. Let's just take a few minutes to practice finding solutions by using the quadratic formula. So let's try 37, let's say 40, and maybe 41 as well. Let's go ahead and try these two and find the solutions. Well, in number 37, I think it's a good idea to identify A, B, and C values. My A value, of course, is 1, and my B value is 4, but my C value I'm going to call -21. Do you recognize why? If you have questions, please let me know. But my C value is -21. If my job is to find the solutions, or if I'm being asked to solve, then I'm going to use my quadratic formula with a plus sign, and I'm going to use my quadratic formula with a minus sign, and I'm going to evaluate it at the appropriate A, B, and C values. So 1, 4, and -21. So if I reach for the calculator and complete those computations, QFP and QFM are what we need. So QFP evaluated at 1, 4, and -21. And QFM at 1, 4, and -21 as well. So it looks like our solutions occur at 3 and -7. Now what does that mean again to say that these are solutions? Well, we know that they are x-intercepts, we know that they're roots, we know that they're zeros. These are all the same names. But how do I know that 3 is the solution for x and -7 is solution for x? Well, we know that they're solutions if the left side of the equation ends up equaling the right after we make these substitutions. So a quick check can verify that. Does 3 squared plus 4 times 3 equal 21? That's the first check. Well, this becomes 9 and 12. Does 9 plus 12 equal 21? It sure does. So that answer is good. We should also check our other. Does negative 7 squared plus 4 times negative 7 also equal 21? Well, negative 7 times itself becomes a positive 49, and 4 times negative 7 is negative 28. And the question now becomes, does 49 plus negative 28 equal 21? Well, 49 plus negative 28 is the exact same as 49 minus 28. And certainly 49 minus 28 also equals 21. So we know that that was a good solution. These are the only two answers for this quadratic. There will only be two real number answers to this solution, and we found them very quickly by using the calculator to help us. Let's try number 40. With number 40, we again have a quadratic, so we should identify our a, b, and c value if we're going to use the quadratic formula. So a is 1, b is 2/3, and c is negative 1/3. So again, if we're looking for solutions, we better use our QFP with 1, 2/3, and negative 1/3. And we'll also do the same at QFM. Let's see what our calculator gives us here. So QFP with 1, 2/3, and negative 1/3 ends up giving us 0.3 repeating, or 1/3. And QFM, if I rearrange this, QFM gives us a value of negative 1. So we have an x value of 1/3, and we also have an x value of negative 1. Just double checking here. And we have our two solutions. X is equal to 1/3 and x is equal to negative 1. Please try the last example on your own. What's going to happen with number 41? Pause the video now and resume playback in a moment to check your work. So in this case, we got a rather strange answer. Depending on the calculator that you got, you may have gotten a result that looks something like this, with this fraction including a radical sign. And same thing with the quadratic formula with the minus sign. Got a fraction with a radical sign in between it. Or you may have had a calculator that returned a decimal to you. On these TI calculators we've been using in class, a lot of times they do give us an answer in exact form, something that looks like this, with a radical sign and with the the fraction included. And I'll remind you again that if you ever want the decimal copy of that answer instead of the exact answer like this, when we're done with the calculation, let me just show that to you again. I'll just copy and press enter here. If you just press enter, it gives you the exact calculation, but if you turn around and press control enter right after that, the control enter yields this approximate result, or this decimal result. And we can get our decimal answer much easier that way. Now, I like the decimal answers in the event that we're trying to graph this equation, but I like the precise answers if we just need to solve the equation. So if you recall, we have x-intercepts that come from our solutions. So I have no idea where on the x-axis these numbers in purple are, but I could guesstimate where 0.27 is. If this is 1, then 0.27 is right about here, a little bit more than a fourth of the way. And if this is negative 1, then x value of negative 0.6 is right about here. So I have a general understanding on where those data points are. Now I could take this one step further and evaluate the vertex and get a better idea for the shape of the graph. So if I call the vertex command, with an a value of 3, a b value of 1, and a c value of -1/2. Then when I enter that, I get a coordinate of -1/6 and -7/12. Again, those answers are okay, they're nice, but I think by pressing Control Enter and getting the decimal from that, I have a better understanding of what the graph's going to look like. So I now have a vertex of -0.17, I'll just call it that because of rounding, and -0.58. -0.58. So even though I don't know exactly where that is, I have a decent understanding. Left 0.17, so left 0.2 units, a little bit less than a quarter, and down -0.5. So that appears to be this position right about here. See, my scaling's a little bit off. Let's see, this is about 1. So maybe right about here. And again, it's not perfect, especially without a grid. I think I probably should have shifted that one a little bit to the left. But now we have a general understanding. This U-shaped parabolic graph should look something like this. It's going to have to open upwards in order to connect this vertex with the other two coordinates that live on the graph. So you could try the remaining 3 questions on your own. Again, if the instructions simply say to solve, then we can use the quadratic formula to do so. If they ask us to graph the equation, or check your graph with a graphing utility, that means going out to a graphing calculator and checking your work. So let's go ahead and do that with these 3 here. I'm going to use my TI calculator again. If I press Control Dock, I can add a graphs page. Now the first equation was x squared plus 4x equals 21, but I better write that in a more quadratic form. We'll call this x squared plus 4x minus 21. That'll give us the same a, b, and c values that we need. And if I look closely here, I can't just tap on the screen, but I can look at my scale. Each grid line is worth 1 unit, so we have an x-intercept at 1, 2, 3. So we have an x-intercept at +3, and another x-intercept at 1, 2, 3, 4, 5, 6, 7 units to the left of the origin, so 3 and 7. So not only did we check our answer with the algebra, but we've also checked our answer by graphing as well. So it's a double check, if you will. For number 40, I need an equation that has an a value of 1, b value of 2/3, and a c value of -1/3. So if I press the tab button, whoops, let me escape out of that. Press the tab button, try it one more time. Tab button, that brings up my formula bar up top. I can erase the a, b, and c values if I need to. So my a value is still 1. My b value is going to be 2/3. I'll just write that as 2 divided by 3. And my c value is -1/3. And press graph. A value of 1, b value of 2/3, c value of -1/3. It's exactly what we have here in the first function. 1, 2/3, and -1/3. Now finding the x-intercepts here is a little bit more difficult. I do see an x-intercept of -1. That one looks pretty clear. I'm okay with that as an answer. But this 1/3, I'm not 100% sure if I see that here. I can't tell if that's 1/3 or a half or maybe a quarter or something like that. So we'll remind ourselves that we can find the x-intercepts by pressing the menu button and analyzing the graph. But another name for x-intercepts we've learned is zeros. So we'll ask the calculator to find the 0 for us. Now the calculator is basically asking us for boundaries. Where should we find the zeros? We have to be fairly specific. So if I click here and drag to the right, I'm essentially creating a window that the calculator is going to look inside to find a 0 or an x-intercept. So within that window that I just selected, we do have an x-intercept of 0.3 repeating, which is the same as 1/3, and I think I'm happy with this result. We verified with a graphing utility. Now finally, in our last example, let's use an a value of 3, b value of 1, and a c value of -1/2. So we can press the tab button, and jump up into the equation. We've got an a value of 3, a b value, let's try to delete this fraction here. There we go. I forgot my b value of 1 and c value of negative 1/2. B value of 1, c value of negative 1/2. Okay, so A is 1, A is 3, B is 1, C is negative 1/2. Go ahead and graph. Now my x-intercept has moved now that I have a new equation. That's at point 2742. And for my other x-intercept, let's go ahead and use the analyze graph option to find a 0 over here. Need to provide a new window. And I don't think either of those answers are what we had originally seen right here, but if I compare it to the decimal coordinates that we've got, 0.2743 and 6076, they seem to match pretty well. So 6076 and 2743 when rounded. Now the other feature that we found by hand in this example was the vertex, which is going to be the low point of this graph. Let's go ahead and find what that is. We can press Menu, Analyze Graph. And there is no command for vertex, but I do know that the vertex falls at the bottom of the graph. In this case, it's a minimum of the graph. So if I create a window to find that coordinate, I see that I have an x value of 0.17 and 0.58 when rounded. And that indeed matches what we had here as well. So our calculator does give us lots of methods for us to solve these equations and find different characteristics of the graphs. I think this is a pretty good stopping point right here, and I would challenge you to complete the remaining examples that we skipped in this video. The instructions down here were more about completing the square, but we'll go ahead and skip that for this lesson today too, because the video is getting a little bit long. But if you'd like extra credit or bonus opportunities, go ahead and finish the 3 questions from this group that we didn't complete and the 5 questions from up here, and I'll consider that for bonuses on the assignments this week. If you have questions, please let me know. Otherwise, thanks for watching.